Let's go back to our last example where we were to roll a die. We were to suppose that we wanted to roll a 2. We were going to call the event rolling a 2 a success, and then if we roll anything else, we'd consider it a failure. We found the probability that our first 2 would happen on the second roll, and let's recall that in order to do that, we have to have a failure, and the probability of a failure is 5/6, and then we would have to have a success, and that probability is 1/6. If our first success, or in other words, the first 2 that we roll, happens on the third roll, what is that probability? Well, we'd have to have 2 failures then. So, and since we're multiplying, we can call that 5/6 squared, and then we have our first success, 1/6. Now let's do this. Let's formalize some of this notation. Let's let P be the probability of a success. And then let's let Q be the probability of a failure. And let's do this. Let's let K be the number of times we roll until our first success. So the probability then that that number K is equal to 2 would be our 5/6 times 1/6. The probability that K would equal 3 would be 5/6 squared times 1/6. The probability that K would equal 4, we'd have to have 3 failures before we had our first success. The probability that K would equal 5, we'd have to have 4 failures before our first success. The probability that K would be 6, we'd have to have 5 failures before we had our first success. So, one thing we left out up at the top here was the probability that K would equal 1. And that would just be the probability of rolling a 2, or the probability of a success. But what we notice here is that the number that we have for K, if we subtract 1 from that, we get the exponent on the probability of a failure. So we take the number that we have for K and subtract 1 from that, and we wind up with the exponent, or the number of times we would have to have a failure until we get our first success. So we can generalize this into a formula. Now remember that we used X as our variable whenever we were talking about random variables. And again, this is an example of a discrete random variable. It can only take on counting numbers. And the formula would look like this. The probability that X would equal some K value, any one of these K values that we have here, is going to be Q, which is the probability of a failure, raised to the K minus 1 times P, the probability of a success. And the name for this particular distribution is the geometric distribution. And this formula is our formula for finding probabilities associated with a geometric probability distribution.